Hey there everyone, Ryan Schul here. Welcome to my channel. I'm going to do camera off today because I have some family visiting and things get really chaotic and spin out of control really quick, and I don't want a lot of stuff in the background. So in the narrative today, I want to look at how we can calculate the probability of a real estate transaction actually closing, right? Or actually coming to fruition and you close the deal, right? So I was sitting with a friend having dinner Sunday night and we were talking about this. His wife works in real estate business and he said, a lot of times the wife is just sitting around, just waiting for things to happen, just sitting around, sitting around, sitting around. There's a lot of sitting time, right? I don't know if that's the official term, but that's how it seems like to me. So I thought, like, if we collect some information, and we should have this information. Like, I'm not a real estate agent, so I don't know exactly what kind of data they have access to, but they should have client data that they're doing background checks, validating people's income, status of job. Are you employed? Or are you not employed? They should have some basic data. Okay, I don't have that data, so I created my own synthetic data, and I'm going to leverage that. And we'll see that in just a minute. But even why would we even want to do that, right? We can generate the synthetic data, and the purpose is to try to compute each client's maximum rent payments, right? What's the maximum that they were able to pay, or the maximum purchase price? And there's really no minimum here because minimum would be zero. Everybody can afford zero, right? But for different clients, there has to be a maximum rent that they can afford and a maximum purchase price that they can afford. So I'm going to look at propensity scores for renting and buying and using a heuristic, sorry, I mispronounced that, heuristic, to try to understand and generate probabilities to generate in a real model, okay? And there's illustrative heuristics, not lending. This is not lending advice, okay? And for actual underwriting, you would have to speak to lender-specific entity, right? And look at their rules and their actual rates. So this is a hypothetical, but it should be pretty realistic. And by the way, what is a heuristic? It's basically a practical rule of thumb method for making decisions or finding solutions quickly when an exact or guaranteed optimal method will be very slow, costly, or just completely unknown. Like sometimes you run a model and it can't converge, right? The model can never finish its calculations because it's always searching for new information, right? But if you let the model run for 6 hours or 8 hours or 10 hours and you have no result, is that actually helping you? No, I don't think that does anything, right? You just wasted 8 hours of your day. You burned through an entire day and you got no results, right? But if you can use a heuristic and get your results in a couple seconds, and it's very, very, very accurate, but maybe not the optimal solution, with 15 decimal places of precision, but it's pretty darn close, you should go with a heuristic every time, right? If you can sacrifice a little, what would I call it, accuracy for a lot of time savings, then you should go down that path and not waste your time, right? So let me get into it. I can generate the synthetic data right here. I'm looking at people's titles: software developer, teacher, driver, administrator, plumber, mechanic, things like that. Okay, I'm going to look at the job status and the person's degrees. Do they have a college degree? Do they have a master's degree? Do they have a high school degree? Right, and I want to know the level of the education because I think that will have an impact on the person's ability to pay the rent or to pay the mortgage if they end up buying their place. But there's no direct correlation between education and income. There is a slight positive correlation. There may be a strong positive correlation, but there's nothing that guarantees you get a PhD and you're going to be the top income earner in your class, right? If you get just an associate degree, you're going to be the bottom income earner in your class. It doesn't work like that, right? There is some correlation. I'd like to see an analysis of that, actually. I don't know what the correlation would be like, but I'm guessing there is a positive correlation, and it might be strong too. But again, I don't have that data, so I'm making it up just to illustrate the point of how to do this, right? So we have household size, marital status, number of dependents, job title, education, college degree, yes or no, years of experience in your role, and years in your current role. So if you've been working in your current role for 10 years, that's probably a stronger indicator of somebody being able to afford higher rent or higher purchase price for a mortgage than somebody that has been job hopping for 20 years, right? If you had the same job for 10, it's probably more consistent and persistent than somebody that's turned a different job every year for 20 years. Okay, so that's the expectation here. We're going to look at each person's savings, the monthly debt. Almost everybody has debt. Not everybody does, but a lot of people do. Ability to borrow. This would be your credit, right? What kind of credit score are you going to be able to achieve? Rent years. Do you have any evictions? That's a red flag right there, right? And then the timeline, and as well as income ranking, right? And median rents. We're going to look at these. So median prices to rent and to purchase a price, and these all have an impact on the person's ability to effectively pay a higher rent or to pay a higher mortgage. So we're trying to collect all this information and quantify how likely is it that a deal will close and the real estate agent can go meet that party that will potentially rent the space that you're offering or buy the place that you're trying to sell for the homeowner. And what is the probability of that transaction sticking, right? That's what we want to try to understand. If it's like 2% chance of that working out, is it really worth your time as the agent to go and sit in that spot, in that either rental place or house that you're trying to sell? 2% is a pretty low number. I don't think that's worth it. If you're getting more like 12% of the time the purchase is going to occur, 14% of the time, 15% of the time, that's a much higher probability, right? Times 2, that's almost 8 times more likely to result in an actual sale. That's how you should be spending your time, right? And anybody that is just going to either waste your time because they don't have enough money to rent, or they don't have enough money to buy, or they don't have a history of successful renting. Maybe the person's been evicted once or twice before. You don't want to waste your time with these people, right? So we're going to take all of this, create a heuristic. Let me run this first of all. Let me run this to refresh it in memory. We're going to create a heuristic to try to understand the probability and the potential of these transactions going through, right? I want to see what's going to stick and what's not going to stick. So I created all the code here, and then I assigned some just basic scoring mechanisms over here, and scoring buy, scoring rent. So we're trying to assign scores to quantify this whole process, right? And then in the end, we're going to come up with age, household size, number of dependents, marital status, things like that, right? And we're going to create all of these, append these rows, right, to this list. If I do Control F, you can see rows as a list. I created it over here. List is indicated by these square brackets, right? In the Python world, we have a few different data types. We have lists, we have dictionaries, we have tuples, data frames. Personally, most of the time I use lists and data frames. Sometimes dictionaries are pretty useful. I don't think tuples are super useful. I've used it a handful of times in the 12 years I've been doing this stuff, but I think there's probably a time and a place for those as well. So we get the final data frame down here. I'm doing print shape. We have 500 rows, 31 columns, and we're taking all of these. I have it as sample. Originally I had a sample here. I should probably change the name. I was just looking at the top 12, the head of the 12.agad. And then I decided just to look at all of them, so I took off the sample thing here. So I'm looking at probability of buying, of a buy commit, right? Probability of a buy commit, probability of a rent commit. So this is the buyer committing to the agent. This is the renter committing to the agent. And is this person qualified as a buyer, or is this person qualified as a renter? So that's the data set that we're looking at. Again, 500 rows, 31 columns. If I go to the right, you can see client ID, age, household size, dependents, marital status. And by the way, I'm using ID over here because we want to make this anonymous. We can easily map to the original clients to get the names, their addresses, their phone numbers, things like that. I don't think that needs to be displayed. If you were the data scientist or machine learning engineer, I don't think you need to identify who these clients are, especially when you're talking about sensitive financial information. We have just basic information that is basically anonymous here, right? You can't tie that to a specific client. You don't know who these people are, right? For the agent, we can easily map back, and we can have a process that is abstracted away from the ML engineer and from the data scientist, so they never even see these details, right? But for the agent, I think you do. You actually do need the name and the phone number to follow up with them. So here we have median price in that zip code, median rent in the zip code, job status for this customer, title, educational level. Hopefully this makes sense, guys. Hopefully This is not totally foreign. So college degree, total years of experience, years of current job, annual income, savings, monthly debt payments. Okay, most people have debt. Not everyone does. I don't have any debt. I'm pretty careful with that, but a lot of people do. Credit score for this person. And debt isn't necessarily bad, by the way. If you have a lot of credit card debt, that is bad. That is sinister. That is not going to help you at all. You pay a high interest rate and it's not deductible on your tax return. If you have debt on your mortgage, especially if your house is appreciating or if your condo is appreciating in value, that is good debt, okay? Student debt could be toxic. It could be beneficial. It really depends on what you major in college and what kind of job you get after college. But not all debt is bad. There's some good debt and there's some bad debt. So rent history, years, eviction history. Hopefully we see zeros here. If we see anything other than a zero, that's a red flag. Intent is to buy or rent here. Okay, we can see either one. Move timeline, maximum rent affordable, maximum purchase price, rent affordability ratio. Okay, that's important. 2, how much can you afford to pay in rent based on your income and your debt? We consider all of these things, right? Because you have to pay your debt. You have to pay your credit card payments every month or you're going to go into default. And I think it's called, what is it? Insolvent. You can become insolvent, right? So you have to pay your debt. So that is going to affect your affordability ratio. This is buy affordability ratio, all right? And this is what we're trying to calculate right here. So probability of a buy commit and probability of a rent commit. So we can see here, because we're sorting this data frame by these fields, we have probability buy commit, probability rent commit, and then qualified buy, qualified rent. I'm interested in seeing if these people are qualified. So this is how we're sorting this, okay? We're doing sort values and ascending, false, false. These are for the first two variables or arguments right here. I guess this is more of a variable than an argument. It could be an argument, I suppose. So false, false for the first two, true, true for the last two. So these are the last two arguments, true, true. This one is false and this one's false. This is true, this is true. Okay, so it follows this logic right here. True, true. We see probability to buy commit. That's the whole point of this whole exercise here, guys. What is the probability that this person is going to buy this piece of real estate, this house or this condo or co-op that we're selling? Probability of rent commit. So this is 20% of the time. So I would spend time with this individual. You'll never get 100% for anything, right? There's no guarantee of anything in this world. But 19% of the time, 19.5% of the time, this is a go. This is a green light. This is a little bit lower because we're sorting in descending order, right? Ascending equals false. So ascending equals false means descending. So we have 19.5, 19.4, and then 17.4% of the time this person is going to rent. 17.1% of the time this person is ready to rent. Is this qualified renter? It says false here. Probably they don't earn enough, or the person has too much debt. And this says qualified buy, false, false. So this person on the bottom row, we have false and false. Let's see what's going on over here. If we go back here, executive assistant. So that's not a high paying job as far as I can tell. I'm not making any judgments here, but probably not earning 6 figures. So annual income is 52,000, sorry. Savings is 51,000. That's pretty good savings. So that's good. Monthly debt payments is 367. Credit score is 701. So pretty high credit score. Rent history 11. I think the problem with this person is that they do have some debt and the income is kind of low over here, right? So low income and some debt is not a good combination for qualified renter or qualified buyer, and the person only makes 52,000. So we have a lot of falses over here. So we have a lot of low incomes. This actually says true. So if we follow this line over, let's see what's going on with this person. So here's the person. Median price zip is 859,000. If we go a little bit to the right, it's a software engineer. So I'm guessing this person has a pretty decent income package. If I go over here, 89,000 per year. So that is pretty good, right? This one's making 52,000. That's why they don't qualify. This person's making 89,000. So they have a lot higher potential to qualify. Debt payments is only 243. This person actually makes more. So this is 97,000 in income. Debt is 1,381 per month, right? So that's over 12,000 per year in debt, and they make 97,000 after tax. That's going to be less, probably closer to 87, maybe even 80,000 if you live in California or in New York. You're paying 12,000 per year in debt. You make 80,000. So your income is much closer to what this would look like, 68,000. Plus you're paying rent right now. And it's just kind of not really a good scenario to be able to buy or to rent. So you see false, false over here. Now, again, you can tweak this a little bit. This is the logic I came up with. These are the results that I found. So if you have actual real estate data and real client data, you can certainly tweak the model and the process here a little bit. But I think this is a very good first pass with this thing. I'm pretty happy with the way it turned out. If I go down here, we can see, again, we're doing the sort, data frame sort, false, false, ascending equals false, ascending equals false. So we're sorting in descending order. This is probability to buy commit, probability to rent commit. So the head over here, these are the people that you want to spend most of your time with. This is the crowd down here that you want to spend less of your time with because they're not going to be able to qualify for a lot of things over here. You can see qualified rent and qualified buy, everything is false over here. The probability buy commit is only 0.14. Over here, it's 0.195. So this person is 19.5% likely to commit to buying real estate. This person is only 14% committed to buying. This person down here is 12% committed, right? So much lower numbers. Anything that falls into this bucket, you probably shouldn't be spending a whole lot of time with these people if time is valuable to you. Now, if you have nothing but time to burn, maybe it doesn't matter. My time is pretty valuable to me, so I try to be efficient. So anyone in this bucket, I wouldn't personally spend a whole lot of time with. Try to be helpful. If I already have an appointment coming out, if I have this guy coming out, I can coordinate with this guy, but they have to come at the same time. I'm not going to make a special appointment for this guy. I'm certainly not going to bend over backwards for this guy down here. That's probability to buy, probability to rent. This is 17.4. Probability to rent, this is 17.5, down to 13, down to 16. So again, decreasing likelihood that these people are going to do business with you. 16% of the time, this is going to work out. 17% of the time, it's going to work out. 19% of the time, it's going to work out. Only 12% of the time, this is going to work out. Okay, so I have some notes here. A few records look a little bit bizarre, but this is because we encounter clients who have low annual income, like 10,000. Some of these incomes are pretty low, and higher debt. So this is a toxic combination, right? If you have low income and high debt, let me see if I can find a couple records. When I initially ran this, I saw some. Annual income, lower income, only 15,000. Wait, 154,000. I'm sorry. So this one, no, 15,000. I was right, 15,000. So that's pretty low income for this person, right? Savings is 13,000, which is good, but the income is pretty low. 15,000 might be a student. I'm not sure what this person is. Restaurant server. Okay, so restaurant server, not making a ton of money. Kind of makes sense, right? Monthly debt payments is $425. Like, this could be a very nice person, but in terms of them giving you business for buying or for renting, we're only looking at 13.6% of the time it's going to work out to buy. And to rent, obviously renting is easier than buying, right? You can get into the market with less money. So the probability of renting is slightly higher. It should be pretty much higher in all these scenarios. There could be one or two exceptions, but not too many. But you'll see some results like that. 15,000 income doesn't really qualify to buy, doesn't really qualify to rent. The maximum rent for this person would be $845 a month. Maximum purchase price is $1,368. Wait, was that the same person? Let me see this. Was that the restaurant person? Oh, restaurant server. That's the line above it. Sorry. So, maximum rent affordable. Yeah, this is kind of an anomaly right here, right? So I wouldn't spend too much time on this, and this is kind of low anomaly. This I kind of like tapered that down to 0 in the logic, because if your rent is that low, we're just doing a calculation using your heuristic, right? So you see a couple records that look kind of funky. Nobody's rent is $27.47 per month, right? But the heuristic comes up with that because it's trying to make an attempt to do something very quick and very accurate. But sometimes things just get a little bit wonky here, and that's okay, right? And this is made up synthetic data. If you had real client data, you could actually get like a real rent, right? And this could be low rent. It could be maybe $270 a month or something like that. I guarantee it's not 27, but in most cases, the heuristic is working out. You could get a couple of outliers right there where it looks kind of funky. But again, that's also because the income is pretty low, $15,000 for that person, and they have debt, right? So some records could be a little bit bizarre. We can just ignore those for our purposes here. So for purchase price, the debt to income ratio can basically kill the borrowing power, right? You don't want to have too much debt. I think I've said that a few times. The commit probability model is not tied tightly to affordability. It also considers credit, intent to buy, timeline stability, and et cetera, et cetera, et cetera, right? So we take all this, mix it up in a blender, and the heuristic spits out a result. If you had real world data, the person could be a hot lead, but have no budget, and the agent could work with this person, but they would need some kind of cosigner, or needs a cheaper market, or just simply does not qualify for the rent or for the loan. And again, you shouldn't be wasting your time with this person. So anyone in this bucket down here at the end, that's why we're doing a sort, okay? So hopefully that makes sense. We're sorting by probability to buy, commit, probability to rent, in descending order, right? I've said that a couple times. Hopefully it makes sense. So that's what we're focusing on right here. That and that. Anybody in this bucket at the top here, the top 10, we're looking at the top 10, that's what you should be focusing on. Anything in the bottom 10, the head is the top, the tail is the end. Anything in the bottom 10, don't even waste your time, guys. If you're a real estate agent, don't waste your time with that, because that is going to be fruitless. Okay, I'm going to go ahead and save this, and I will share all the code with you guys when I drop the file. I'll put this up on YouTube a little bit later today, and you'll have all the code and the video to go with it. You can download the code sample, copy paste it, run it in your own environment, and of course tweak the code, experiment with it, re-engineer it, take it apart, put it back together, and just have some fun with it. Okay, so that is my take on calculating the probability of a real estate transaction actually closing. So thank you for sticking with it to the end. Appreciate that, guys. And I'm going to wrap it up right here. I will see you in the next video. Talk to you soon.